Late afternoon. June 1944. Somewhere above the western Pacific, nearly 200 miles from the nearest carrier deck, the sky stretched empty in every direction. A single Grumman F6F Hellcat cruised at 18,000 feet, its engine humming with steady mechanical confidence. Below, the ocean reflected sunlight like shattered glass, endless, indifferent, silent. Inside the cockpit, heat gathered beneath the canopy. The pilot's oxygen mask moved with slow, controlled breathing. Fuel gauges were checked again. Radios remained quiet. Combat air patrols were often like this, long hours of waiting suspended between boredom and sudden violence. American carriers operated far from land now, striking deeper into Japanese defenses than ever before. Most encounters ended before they began. Then the radar controller's voice broke through the static. Multiple contacts. Fast. Closing. Tiny black shapes appeared against the sun, first indistinct, then multiplying. One aircraft became three. Three became many. Within seconds, their formation spread wide across the sky, maneuvering, climbing, positioning. The lone Hellcat was no longer hunting. It had become the target. And the reason this moment existed began years earlier, when the balance of air power in the Pacific was still uncertain. In December 1941, the balance of air power over the Pacific Ocean belonged almost entirely to Japan. When aircraft from the Imperial Japanese Navy Air Service struck Pearl Harbor, they revealed a form of warfare the United States had not yet fully understood: long-range naval aviation executed with precision, coordination, and combat experience gained through years of expansion across Asia. Japanese carrier pilots were not simply well-trained. Many were veterans of continuous operations in China since the late 1930s. They had practiced formation flying, coordinated strikes, and aerial combat under real battlefield conditions long before American forces entered the war. Their primary weapon in the sky was the Mitsubishi A6M0, lightweight, agile, and capable of extraordinary range. Against early American fighters such as the F4F Wildcat, the Zero could climb faster, turn tighter, and often dictate the terms of engagement. During the first months of the war, this advantage proved devastating. Across the Philippines, the Dutch East Indies, and the Solomon Islands, Allied air units struggled to adapt. American pilots learned quickly that traditional dogfighting tactics could be fatal. Turning battles favored Japanese aircraft. Many early engagements ended with American fighters shot down before pilots fully understood their enemy's strengths. But beneath Japanese success lay a fragile reality. Japan's naval aviation system depended on an elite corps of highly trained pilots produced through an extremely selective and lengthy training pipeline. Becoming a carrier pilot required years of preparation. The system emphasized quality over quantity, producing aviators of exceptional skill, but in limited numbers. Losses, once sustained, were difficult to replace. The United States operated differently. American industry and military planning increasingly embraced scale. While early defeats shocked commanders, they also accelerated reform. Training programs expanded rapidly across the continental United States. Flight schools multiplied. Standardized instruction replaced individualized elite preparation. The goal was not merely excellence, but sustainability, a continuous flow of competent pilots able to operate within coordinated systems. The turning point began during the brutal campaigns around Guadalcanal in 1942. There, American pilots faced Japanese airmen repeatedly over contested waters known as Iron Bottom Sound. Combat was relentless. Both sides suffered heavy losses, but the nature of those losses differed profoundly. Japanese veterans, irreplaceable leaders of squadrons, were gradually worn down. Each experienced pilot lost represented years of training and combat knowledge disappearing forever. American losses, though painful, were increasingly replaced by newly trained aviators arriving from expanding flight programs. At the same time, American engineers studied combat reports carefully. Pilots described what worked and what failed. They learned that survivability mattered as much as maneuverability. Armor protection, self-sealing fuel tanks, and heavier firepower could mean the difference between returning home or vanishing into the ocean. Early fighters like the Wildcat had survived not because they outperformed Japanese aircraft, but because pilots learned disciplined tactics, diving attacks, mutual support formations, and strict energy management. These lessons reshaped naval aviation doctrine. Meanwhile, radar technology quietly transformed the battlefield. Ships could now detect incoming aircraft beyond visual range, allowing fighters to be guided toward enemies rather than searching blindly across vast skies. Combat was becoming less about chance encounters and more about controlled interception. By early 1943, the Pacific War was no longer defined solely by daring Japanese offensives. American shipyards launched carriers at unprecedented speed. Air groups expanded. Logistics networks stretched across newly captured islands. The United States was preparing not just to resist Japanese air power, but to overwhelm it. Still, one critical problem remained unresolved. American pilots needed an aircraft designed specifically to defeat the Zero without sacrificing durability or range. Engineers understood that survival, firepower, and speed had to replace the fragile elegance that characterized early Japanese fighters. Somewhere in American factories, a new aircraft was already taking shape, larger, heavier, and built around the hard lessons written in the skies of 1942. And once it entered combat, the nature of aerial encounters in the Pacific would begin to change in ways neither side could fully predict. By mid-1943, the Pacific War had entered a new phase, one defined less by desperate survival and more by calculated momentum. American naval planners understood that victory across the Pacific would not come from a single decisive battle. The ocean was too vast, the distances too extreme. Instead, the United States adopted a methodical advance later known as island hopping, a campaign designed to push carrier task forces steadily closer to Japan while bypassing heavily defended strongholds. Air superiority became the essential requirement for every step forward. To achieve it, the U.S. Navy introduced a fighter built not for elegance, but for dominance, the Grumman F6F Hellcat. The aircraft's design philosophy reflected brutal honesty. Engineers at Grumman studied pilot reports from earlier battles and asked a simple question: what allowed pilots to survive combat against the Zero? The answer was not tighter turning ability. It was strength, speed in a dive, heavy armament, and the ability to absorb damage long enough to escape. The Hellcat embodied these lessons. Powered by a massive Pratt & Whitney R2800 engine, the fighter delivered reliability as much as performance. It climbed well, accelerated strongly in dives, and maintained control at high speeds where lighter Japanese aircraft struggled. Thick armor protected the pilot. Self-sealing fuel tanks reduced catastrophic fires. 6.50 caliber machine guns provided concentrated firepower capable of destroying enemy aircraft in brief firing windows. Most importantly, the Hellcat was forgiving to fly. Unlike earlier fighters that demanded exceptional skill, the F6F allowed relatively new pilots to operate effectively after standardized training. This characteristic aligned perfectly with America's expanding pilot production system. Thousands of aviators graduated from flight schools each year, trained not as individual aces but as members of coordinated teams operating under doctrine and radar control. At sea, another revolution was unfolding. Fast carrier task forces. Mobile fleets built around multiple aircraft carriers, operated as unified striking weapons. Radar picket ships extended detection ranges. Fighter direction officers guided pilots toward incoming threats using precise vectors transmitted over radio. Aerial combat increasingly began before opposing pilots could even see each other. For Japanese aviators, this change was profound. Encounters that once relied on surprise now often began with American fighters already positioned at altitude advantage. The sky itself seemed organized against them. Industrial capacity amplified the shift further. American factories produced aircraft at a pace unmatched in history. Replacement planes arrived faster than combat losses could reduce them. Maintenance crews aboard carriers worked around the clock, ensuring fighters returned to combat within hours. Logistics ships delivered fuel, ammunition, and spare parts across thousands of miles of ocean. Japan faced a growing imbalance it could not easily correct. Combat losses among experienced pilots accelerated through 1943. Training programs shortened in an attempt to replace them, but newer aviators entered battle with fewer flight hours and limited combat preparation. Aircraft quality remained high in certain designs, yet pilot experience, the invisible factor that once defined Japanese superiority, steadily declined. By early 1944, statistics began revealing a stark transformation. Engagements increasingly ended with disproportionate Japanese losses. American pilots reported greater confidence, not because combat had become safe, but because their aircraft allowed them to fight on their own terms. The Hellcat did not eliminate danger. Pilots still faced anti-aircraft fire, mechanical failure, and the unforgiving Pacific Ocean below. But the balance of probability had shifted. Survival was no longer dependent solely on individual brilliance, it was supported by engineering, doctrine, and coordination. Carrier air patrols expanded farther from the fleet, intercepting threats before they reached American ships. Lone patrol aircraft sometimes found themselves deep between advancing American formations and desperate Japanese counterattacks, isolated points where large forces could suddenly converge on a single fighter. It was within this new reality that encounters became increasingly uneven. A single aircraft might suddenly meet many. And on one patrol in 1944, far from the reassuring outline of a carrier deck, one Hellcat pilot would discover exactly what that imbalance meant when 12 enemy fighters turned toward him at once, transforming strategic change into a personal fight for survival. By 1944, aerial combat in the Pacific was no longer decided by aircraft alone. Victory depended on how humans, machines, and tactics merged inside seconds of decision-making at thousands of feet above the ocean. To understand how one pilot could survive against overwhelming numbers, the story must be seen through several overlapping angles, each shaping what happened long before the first shots were fired. Combat reports often reduced aerial battles to numbers, altitude, ammunition spent, enemy aircraft destroyed. But inside a fighter cockpit, war existed as sensation rather than statistics. A Hellcat pilot operated in constant physical strain. The cockpit was cramped, loud, and hot despite high altitude. Engine vibration traveled through the seat and control stick. Oxygen masks restricted breathing. Visibility depended entirely on head movement, there were no rear-view mirrors capable of revealing every threat. Situational awareness became survival. Pilots scanned the sky continuously. Above, below, behind, knowing that a moment's distraction could be fatal. Against multiple enemies, the psychological pressure intensified rapidly. Human vision struggled to track more than a few moving objects simultaneously. 12 aircraft attacking from different directions created cognitive overload, forcing the pilot to prioritize instinct over analysis. Training attempted to prepare aviators for this chaos. American naval pilots practiced defensive maneuvers repeatedly, brake turns, high-speed dives, rolling reversals. These actions had to become reflexive. There was no time to calculate during combat, hesitation meant vulnerability. Fear existed, but discipline controlled it. Veterans later described combat not as panic but as extreme focus, a narrowing of awareness where every motion became deliberate. The goal was simple. Stay alive long enough for opportunity to appear. In such moments, loneliness became unavoidable. Radio communication often dissolved into fragmented transmissions or silence. A lone pilot separated from formation understood one reality clearly: rescue depended entirely on personal skill and aircraft capability. The aircraft itself shaped the possibilities of survival. The Grumman F6F Hellcat represented a philosophy opposite to many Japanese designs. Where earlier fighters prioritized agility through lightweight, the Hellcat prioritized resilience and power. Its radial engine could absorb damage and continue operating. Armor plating protected critical areas around the cockpit. Self-sealing fuel tanks dramatically reduced the likelihood of fire, one of the most feared causes of death among pilots. Equally important was firepower. 6 wing-mounted .50 caliber machine guns created dense streams of ammunition. American pilots were trained to fire only at close range, maximizing destructive effect while conserving limited rounds. Japanese fighters, many derived from earlier Zero concepts, still possessed superior turning capability at lower speeds. But this advantage carried weaknesses. Light construction meant limited protection. High-speed dives stressed their airframes. Sustained damage often proved catastrophic. Technological differences changed tactics fundamentally. American pilots avoided turning contests whenever possible. Instead, they relied on speed and altitude, attacking from above, firing briefly, then climbing or diving away before enemies could respond. Against multiple opponents, durability became decisive. A pilot who survived the first attack pass retained the ability to maneuver. Even minor protection advantages multiplied over time, allowing one aircraft to endure what earlier fighters could not. Technology did not guarantee victory, but it expanded the margin between life and death. Perhaps the most important transformation of the Pacific Air War was conceptual rather than mechanical. American naval aviation increasingly embraced energy fighting, a tactical philosophy emphasizing altitude and speed over turning performance. Pilots were taught to treat altitude as stored energy, potential motion that could be converted into speed during attack or escape. Entering combat from above provided options. A diving aircraft accelerated rapidly, gaining firing position while reducing exposure time. After firing, the pilot climbed back to altitude, preserving energy advantage. This doctrine proved especially effective against numerically superior opponents. When facing multiple attackers, turning tightly only bled energy, leaving the aircraft slow and vulnerable. Instead, Hellcat pilots were trained to keep moving vertically, diving to escape concentrated attacks, then climbing again to regain advantage. The goal was not to defeat all enemies simultaneously, but to prevent them from coordinating. Enemy formations depended on mutual support. High-speed vertical maneuvers disrupted that cohesion, forcing pursuers to separate. Once separated, individual attackers became vulnerable targets. Radar direction and formation tactics usually ensured American fighters avoided isolation. Yet vast Pacific distances sometimes created gaps where a single patrol aircraft encountered unexpected enemy groups. In those moments, doctrine became survival instinct. The lone Hellcat pilot did not need to outturn 12 aircraft. He needed to outthink their geometry, forcing them into a series of individual engagements rather than a coordinated attack. And as the sky filled with converging aircraft, another perspective shaped the battle just as strongly: the reality faced by the Japanese pilots themselves, whose war in the air had begun to change in ways few outside their cockpits fully understood. By the summer of 1944, aerial battles over the Pacific were shaped not only by machines and tactics, but by invisible pressures carried by the pilots themselves. The encounter between one American fighter and many Japanese aircraft cannot be understood without examining the circumstances on both sides of the sky, circumstances formed by years of war, loss, and shifting expectations. Early in the war, aviators of the Imperial Japanese Navy Air Service had entered combat with unmatched confidence. Their training emphasized precision flying, aggressive maneuvering, and absolute commitment to mission success. Many had accumulated hundreds of flight hours before ever facing an enemy. By 1944, that reality had changed dramatically. Attrition had steadily removed the experienced corps that once defined Japanese naval aviation. Veterans lost at Coral Sea, Midway, Guadalcanal, and subsequent campaigns could not be replaced quickly enough. Training programs shortened under wartime pressure. New pilots often arrived at operational units with far fewer flight hours and limited gunnery practice. Aircraft remained capable, but experience, the most critical advantage in aerial combat, diminished. Younger Japanese pilots increasingly relied on aggressive attacks to compensate for uncertainty. Doctrine encouraged closing distance rapidly and engaging in turning fights, tactics that had worked earlier against less capable opponents. Against Hellcat's flying energy-based tactics, however, such aggression sometimes placed them at disadvantage, forcing repeated climbs and dives that consumed fuel and fractured formation cohesion. Communication also suffered. Coordinated attacks required precise timing and mutual awareness, yet inexperienced pilots struggled to maintain formation discipline during high-speed engagements. From their perspective, encountering a lone American fighter did not necessarily appear dangerous at first. Numerical superiority suggested an easy victory. But the battle's outcome often depended on whether that superiority could be organized effectively, something increasingly difficult under combat stress. Thus, the 12 aircraft closing on the Hellcat carried not only weapons, but the accumulated strain of a shrinking aviation system fighting to maintain relevance in a changing war. While Japanese aviation struggled with replacement and adaptation, American leadership focused on systematizing success. U.S. Navy commanders viewed aerial combat as a coordinated extension of fleet operations rather than individual duels. Pilots trained to operate within layered defenses. Radar detection, fighter direction officers, combat air patrol rotations, and strict communication protocols. Every aircraft was part of a larger network designed to reduce uncertainty. Leadership emphasized survivability alongside aggression. Pilots were encouraged to disengage when conditions became unfavorable, a stark contrast to earlier cultures of aerial combat that prized individual heroics. Survival preserved experience, and experienced pilots strengthened future missions. Debriefings became critical learning tools. After every flight, pilots documented encounters in detail, enemy tactics, altitude advantages, weapon effectiveness, and mechanical issues. Engineers, tacticians, and instructors analyzed these reports, continuously refining doctrine. This feedback loop created cumulative advantage. Lessons learned by one pilot rapidly spread across entire air groups. Over time, American naval aviation evolved into a learning system capable of adapting faster than its opponent. The lone Hellcat pilot carried this invisible support into battle. Even when isolated physically, he relied on standardized procedures practiced countless times during training. Decisions made in seconds were shaped by years of institutional learning behind him. Leadership, therefore, existed not only on carrier bridges but inside muscle memory, guiding actions when conscious thought became impossible. Aerial combat often appeared romanticized in wartime propaganda, yet pilots themselves understood its stark simplicity. The sky allowed little room for ideology once combat began. Survival became immediate and personal. Both American and Japanese aviators faced the same physical truths: limited fuel, finite ammunition, fragile machinery suspended above an unforgiving ocean. Parachuting into the Pacific frequently meant death by exposure, drowning, or capture far from rescue forces. The moral burden of combat emerged afterward, in reports listing destroyed aircraft, in empty bunks aboard carriers, in the realization that survival depended partly on chance. For the American pilot confronting multiple enemies, the objective was not glory. It was endurance. Each maneuver aimed to extend time, another minute of fuel conserved, another attack avoided, another opportunity to escape forming somewhere beyond the chaos. For the Japanese pilots, duty demanded persistence even as circumstances worsened. Orders required interception of American aircraft threatening fleet or homeland defenses. Withdrawal was rarely emphasized, engagement remained expected. Thus, the coming battle represented more than a tactical encounter. It embodied two wartime philosophies meeting at a single point in the sky, one shaped by industrial adaptation, the other by fading elite tradition. And as formations converged and distance collapsed between aircraft, abstract differences vanished. Engines roared louder. Shapes sharpened into targets. The geometry of combat replaced strategy. The moment of theory ended. The fight itself was about to begin. The sun hung low over the horizon, painting the ocean in molten gold. The lone Grumman F6F Hellcat streaked through the sky at 18,000 feet, engine whining like a predator's growl. Calm minutes of patrol vanished in an instant as 12 enemy aircraft emerged from the sun's glare, Mitsubishi Zeros slicing the sky with lethal intent. The pilot's hands tightened on the control stick. Instruments were checked reflexively: fuel, oil pressure, ammunition. None of it mattered in the first moments. Threat identification was immediate, 12 aircraft converging from different directions. Communication radios crackled with static, but no friendly voice answered. He was alone. Training became instinct. The pilot executed a high-side defensive roll, diving slightly to disrupt the attacking formation. The nearest Zero dove alongside, its gun spitting tracer rounds across the Hellcat's fuselage. Sparks erupted where bullets clipped armor plating. The plane shuddered, but held. Each maneuver was precise, yet reactive. The pilot could not aim at all 12 simultaneously. He focused on the closest threats, using vertical maneuvers to control the engagement. Speed became both weapon and shield. The Hellcat accelerated downward, trading altitude for energy, firing short bursts at targets that briefly entered his sights. One enemy aircraft exploded into flames, the others adjusted their approach. Above, other Japanese pilots attempted coordinated attacks. They were experienced enough to anticipate escape vectors, but fatigue and fear fractured the formation. Energy management mistakes became visible. A climbing Zero stalled briefly, its wings catching sun and glare, an opening the Hellcat exploited. A second wave of passes forced the pilot to weave constantly. The canopy became a visual blur of motion, tracers, and glinting metal. Wind buffeted the fuselage, each control input precise yet desperate. He maintained awareness of his ammunition: too little and defense would fail, too much fire wasted reduced his survival margin. Below, the ocean reflected every maneuver. Small whitecaps marked waves, indifferent witnesses to the unfolding combat. The pilot's mind compartmentalized every factor: threat position, altitude, speed, relative energy, fuel, weapon readiness. Each decision was immediate and irreversible. The first casualty on the Japanese side changed the engagement. 1-0, struck by precise short bursts from the Hellcat's wing guns, spiraled downward, disappearing into the Pacific. The remaining 11 reacted, momentarily disoriented. In those seconds, the pilot executed a steep climb, forcing pursuers to chase along vertical vectors rather than horizontal turning battles. He had become a moving target with advantage. But the danger persisted. Another enemy aircraft closed from behind, banking in for a deflection shot. The pilot dove sharply, weaving into the sun to obscure his position. Tracers passed harmlessly above and below. Splintered adrenaline sharpened perception, eye movement, peripheral vision, even the subtle vibration in the stick indicated enemy intent. Every small cue mattered. For minutes that felt like hours, the sky became a three-dimensional chessboard. Each maneuver created opportunity for survival or disaster. The Hellcat's armor and engine absorbed minor hits; without these, he would already be falling into the ocean below. The contrast was stark: Japanese aircraft remained fragile in prolonged attacks. Even a glancing hit could disable them. Energy management dictated the next moves. The pilot executed a high-speed diving turn, trading altitude for horizontal displacement. The Japanese formation fractured slightly, chasing individual targets rather than the Hellcat as a cohesive group. He picked one, fired a brief burst, then banked sharply away, forcing a miscalculation. Another Zero faltered, retreating slightly, giving precious breathing space. At the midpoint of the engagement, situational awareness demanded near-superhuman focus. Every second required evaluating enemy altitude, vector, spacing, and aggression, while simultaneously monitoring his own aircraft systems and physical condition. Heat built inside the cockpit, sweat stinging eyes behind goggles. Oxygen levels made breaths shallow. Muscles ached. Yet every reflex, dive, roll, burst of fire, had been drilled countless times in training and simulator work. And through it all, the Hellcat remained airborne. It was a fragile equilibrium. One mistake, one misjudgment of speed, or one unexpected maneuver from the enemy could tip the balance irreversibly. Yet for now, the pilot had endured the first phase of combat, surviving what appeared almost impossible, 12 enemy aircraft converging on one defender, against overwhelming odds. The opening exchanges had ended, but the battle was far from over. Each pilot still maneuvered for advantage, each machine still capable of destruction. The Hellcat's next choices would determine whether he could emerge alive or be claimed by the unforgiving Pacific skies. The sun now dipped toward the horizon, elongating shadows across the endless Pacific. The lone Grumman F6F Hellcat shuddered as tracers ricocheted off its fuselage. The first phase of chaos had passed, leaving a fragile rhythm of attack and evasion. A deadly dance where every movement could mean life or death. 12 enemy aircraft remained, circling, probing, and pressing for advantage. The pilot's hands were raw from constant control input. Instruments blurred with sweat. The world outside the canopy became a tapestry of tracer lines, glinting metal, and rushing wind. He forced himself to breathe slowly, controlling the panic that threatened instinct over judgment. Energy management dictated every choice. Climbing too high exhausted the engine, diving too steeply risked overspeed. Ammunition was finite. Each burst had to count. He picked targets with precision, firing only at windows where success was likely. 1-0 erupted into flames after a short burst, spinning out of formation. Another clipped the wake turbulence and was forced to break away. The numbers had decreased, but not enough to relax. Enemy pilots attempted to coordinate. They swung in arcs, flanking and attempting pincer movements. Yet fatigue and inexperience betrayed them. Some broke formation to pursue fleeting opportunities, creating gaps the Hellcat could exploit. He used these fractures to escape vertical traps, diving through one gap and climbing out over another, always staying one step ahead. The Hellcat's durability became critical. Bullets tore through wings, fuselage panels rattled loose, and minor fires flared in the engine cowling. Each strike reminded the pilot of the aircraft's limitations, yet the radial engine roared reliably. Every maneuver depended on the plane's ability to absorb punishment, and it did. By now, the pilot relied on instinct rather than conscious thought. Reflexes dictated dives, rolls, and bursts of fire. He tracked enemy positions through peripheral vision, listening to engine notes, feeling vibrations, and sensing incoming attacks before they were fully visible. The air was thick with tracer smoke, the roar of engines, and the unrelenting wind, sensory overload condensed into a single, vital objective: survive. The Japanese pilots, sensing opportunity slipping, pressed with desperation. One aircraft approached from below, banking sharply to gain a firing angle. The Hellcat pilot anticipated the move, executing a sudden barrel roll combined with a high G pull into a steep climb. The pursuing Zero stalled, forced into a shallow dive to recover, and missed its target entirely. Seconds later, a well-aimed burst from the Hellcat downed another enemy fighter. Even as victories accumulated, danger persisted. Enemy aircraft struck from unexpected angles, forcing repeated dives and evasive rolls. Damage mounted on the Hellcat, but careful energy conservation allowed the pilot to maintain an upper hand. His altitude advantage, gained through meticulous climbing after each dive, ensured that potential attacks approached on his terms rather than theirs. Time became both enemy and ally. The sun slipped lower, and the horizon's orange glare masked some movements. Exhaustion gripped the pilot, yet adrenaline sharpened every perception. Each decision had consequences: fire too long, and ammunition ran out; climb too steeply, and speed would drop; hesitate, and the ocean below could claim him instantly. As the engagement reached its climax, the remaining Japanese fighters began breaking apart. Coordination faltered. Some turned back to regroup, others descended too rapidly, opening themselves to counterattack. The pilot seized the moment, diving in calculated bursts, then climbing away to regroup. One by one, enemy aircraft disengaged, leaving the Hellcat battered but intact. The Japanese pilots, sensing opportunity slipping, pressed with desperation. One aircraft approached from below, banking sharply to gain a firing angle. The Hellcat pilot anticipated the move, executing a sudden barrel roll combined with a high G pull into a steep climb. The pursuing Zero stalled, forced into a shallow dive to recover, and missed its target entirely. Seconds later, a well-aimed burst from the Hellcat downed another enemy fighter. Even as victories accumulated, danger persisted. Enemy aircraft struck from unexpected angles, forcing repeated dives and evasive rolls. Damage mounted on the Hellcat, but careful energy conservation allowed the pilot to maintain an upper hand. His altitude advantage, gained through meticulous climbing after each dive, ensured that potential attacks approached on his terms rather than theirs. Time became both enemy and ally. The sun slipped lower, and the horizon's orange glare masked some movements. Exhaustion gripped the pilot, yet adrenaline sharpened every perception. Each decision had consequences: fire too long, and ammunition ran out; climb too steeply, and speed would drop; hesitate, and the ocean below could claim him instantly. As the engagement reached its climax, the remaining Japanese fighters began breaking apart. Coordination faltered. Some turned back to regroup, others descended too rapidly, opening themselves to counterattack. The pilot seized the moment, diving in calculated bursts, then climbing away to regroup. One by one, enemy aircraft disengaged, leaving the Hellcat battered but intact. The Hellcat descended slowly toward the distant glimmer of the carrier deck, each rotation of the propeller bringing the pilot closer to safety and further from the chaotic theater above. Around him, the Pacific stretched unbroken, the ocean reflecting the fading light like molten silver. The adrenaline that had sharpened his reflexes during the encounter now ebbed, replaced by exhaustion and the quiet awareness of what had transpired. The battle report, submitted later that evening, described the engagement in precise, measured terms: 1 Hellcat versus 12 Japanese fighters, 4 of which were confirmed destroyed or damaged. Damage assessments on the Hellcat listed superficial strikes to the fuselage and wing surfaces, minor smoke from the engine cowling, but the aircraft remained fully controllable. From a purely statistical standpoint, the engagement was remarkable. Back on the carrier, the pilot's squadron waited tensely for his return. Radio silence had extended beyond the expected window, leaving crews uneasy. Carriers in the Pacific had learned to balance operational confidence with the grim reality of loss. Each missing aircraft carried a potential tragedy, downed pilots rarely survived long in open water, and rescue operations were complicated by distance, weather, and enemy presence. The landing itself was executed with precision. The pilot's skill, already proven in combat, ensured the aircraft touched down on the deck without incident. Crewmen rushed to inspect the Hellcat, marveling at the extent of damage that the aircraft had absorbed while remaining airworthy. For many, it was a tangible testament to the evolution of U.S. naval aviation, rigorous pilot training combined with robust aircraft engineering. Debriefings followed standard procedure, yet the story unfolded with cinematic clarity. The pilot recounted the sequence of attacks, maneuvers, and critical decisions. Observers cross-checked angles, altitude reports, and timing against radar data and carrier logs. Every shot fired, every evasive roll, and every burst of speed was recorded for analysis. These reports were not anecdotal. They were data points in an ever-growing system of tactical refinement that had already begun to tilt the air war decisively in America's favor. Meanwhile, intelligence analysts examined Japanese aircraft losses, pilot experience levels, and mission reports. They noted a recurring pattern: increasing losses among enemy pilots during engagements with lone but highly capable Hellcats or coordinated American fighter groups. Even when numerical superiority existed, the tactical advantage had shifted. Experienced Japanese aviators, increasingly rare by 1944, were being challenged by new aircraft designs, energy-based combat doctrine, and a growing pool of competent U.S. pilots. The psychological impact on the pilot and squadron was profound. Survivors of extreme encounters often reported a combination of relief, disbelief, and renewed respect for their training and equipment. For the carrier's air group, the engagement reinforced the evolving narrative of technological and procedural dominance. One aircraft, flown by a single individual, could survive impossible odds, a symbol of both human endurance and systemic advantage. Beyond the immediate squadron, the report circulated up the chain of command. Officers at the task force level understood that such engagements were microcosms of a larger strategic reality: American industrial capacity, combined with disciplined training and adaptable doctrine, was systematically overcoming the qualitative advantages Japanese pilots had once enjoyed. Every battle, no matter how isolated, fed into the strategic momentum building across the Pacific theater. Yet amid the analysis and praise, there remained a quiet acknowledgement of mortality. The pilot's survival, while extraordinary, had been fragile. Each maneuver could have been the last. Every ounce of fuel, every second of engine performance, and every bit of pilot skill had combined to tip the balance. It was a sobering reminder that in the Pacific, even mastery of aircraft and doctrine could not eliminate the randomness inherent in aerial combat. As the Hellcat was secured on deck and the pilot finally exhaled, one fact remained undeniable: the Pacific Air War had shifted. The immediate engagement had ended, but its lessons and consequences extended far beyond one patrol, one pilot, and one carrier. The stage was set for the broader impact that would define the coming months of the conflict. The survival of one Hellcat against 12 enemy aircraft was more than a personal triumph. It became a microcosm of the broader transformation unfolding across the Pacific Air War. By mid-1944, engagements like this demonstrated that Japan's early advantage in pilot skill and aircraft agility was eroding under relentless pressure from American industrial capacity and tactical evolution. Statistical trends reflected this shift. Kill ratios, once heavily favoring Japanese forces, had reversed in favor of the United States. For every Hellcat lost, reports indicated multiple enemy aircraft destroyed or damaged. Japanese carrier aviators, once the elite of the Pacific, were rapidly being replaced by undertrained pilots. Even experienced veterans found themselves confronting new American aircraft designed to exploit their weaknesses: robust, heavily armed, and capable of surviving the assaults that would have downed earlier U.S. fighters. The strategic implications were profound. Carrier task forces now operated with a degree of air superiority previously unimaginable. Patrols could extend farther from the fleet, confident that even when encountering multiple enemy aircraft, the odds were increasingly manageable. Offensive strikes against Japanese positions, previously constrained by fear of counterattack, became more aggressive and more frequent. This shift contributed directly to successes in the Mariana Islands and the Philippines later in 1944, where U.S. forces could challenge Japan over vast distances with minimal losses. Japanese command faced stark realities. Training programs could not replace lost expertise quickly enough, and tactical doctrine had not adapted to the evolving threat. While Japanese aircraft remained maneuverable and effective in certain conditions, the systemic advantages built by the Americans, industrial output, pilot training pipelines, coordinated doctrine, and superior aircraft like the Hellcat, created a structural imbalance. Encounters like the one involving a lone pilot against 12 opponents revealed that numerical superiority alone could no longer guarantee victory. Psychologically, these engagements reinforced confidence within American air groups. Pilots understood that survival was a function not only of personal skill but also of collective preparation and engineering. This awareness changed decision-making in subsequent sorties. Commanders could trust pilots to manage isolated situations without immediate reinforcement, while pilots themselves gained a sense of control in high-stakes scenarios. Morale, often underestimated in its influence on combat effectiveness, improved measurably as these success stories accumulated across the fleet. Furthermore, each engagement generated invaluable data. Debriefings detailed altitude management, target prioritization, evasive maneuvers, and damage responses. Engineers adjusted aircraft designs, instructors refined training protocols, and tacticians modified combat doctrine. The battle above the Pacific was therefore mirrored in workshops, classrooms, and command centers, a constant feedback loop accelerating the evolution of American naval aviation. On the Japanese side, the impact was equally tangible. Losses among experienced pilots and the visible survivability of Hellcats eroded confidence. Commanders recognized that attrition was no longer reversible, and risk calculations became increasingly conservative. Aggressive tactics that had once defined Japanese aerial engagements were tempered by fear of catastrophic losses, reducing initiative and cohesion in subsequent missions. Ultimately, the encounter underscored a central truth of the Pacific War: American air power was no longer merely reactive, it had become dominant. Survival, while still precarious, depended on the integration of human skill, aircraft design, and doctrinal sophistication rather than on heroism alone. The lone Hellcat that returned from an overwhelming attack embodied this systemic advantage, a symbol of the shift from Japanese qualitative superiority to American operational dominance. As the pilot finally rested aboard the carrier, the broader implications of the encounter became clear. Individual bravery and skill were crucial, but survival and victory were increasingly the product of preparation, innovation, and industrial might. This engagement, like many others during 1944, foreshadowed the inevitable decline of Japanese naval air power and the emergence of uncontested American air supremacy across the Pacific. A turning point that would shape every subsequent battle, from the Philippine Sea to Okinawa, and redefine the aerial dimension of modern naval warfare. Above the Pacific, the sun dipped below the horizon, casting long shadows over the carrier decks and the endless ocean. The lone Hellcat had returned, its pilot exhausted, the aircraft battered but airborne. On the surface, it was a story of survival, 1 man against 12. But in the larger scope of history, it was something far greater. This encounter revealed the intersection of human courage, technological innovation, and strategic foresight. The pilot's skill mattered, reflexes, judgment, and endurance carried him through the chaos. Yet it was the aircraft itself, the Grumman F6F Hellcat, engineered for resilience and firepower, that turned the tide. Each rivet, every protective panel, each calibrated gun mount was a product of lessons learned over years of Pacific combat. The engagement also reflected the evolution of warfare. The U.S. Navy's meticulous training, doctrinal discipline, and industrial capacity created a system where survival and success were increasingly predictable rather than purely miraculous. The balance of air power was no longer determined by individual aces alone, but by integration, man, machine, and method. Conversely, Japan's reliance on a shrinking cadre of elite pilots highlighted the fragility of experience when unsupported by scalable systems. Beyond tactics and technology, there was a human story, a meditation on courage under extreme pressure. Isolation, fear, and exhaustion were as present as speed and firepower. The pilot's calm under overwhelming odds, guided by training and instinct, serves as a reminder that heroism in war is often measured not by glory, but by endurance, decision-making, and the will to survive. In the wider arc of history, this encounter was emblematic of the Pacific War's turning point. By 1944, American air power had matured into an overwhelming force capable of challenging and defeating superior numbers. The skies over the Pacific had changed. The solitary Hellcat that returned from near-certain destruction symbolized the emergence of a new era, where preparation, innovation, and human determination reshaped the very nature of aerial warfare. The battle ended in minutes, yet its lessons, in courage, strategy, and survival, echoed far beyond the clouds, leaving an enduring imprint on history, and on every pilot who followed in those skies.